Alright, so now we're ready. An object has an average acceleration of positive 5.30 meters per second every second for 0.0256 seconds. At this time, the object's velocity is this. What was the object's initial velocity? Alrighty. So, alright, so this is number one, and I would start off in my y with things like acceleration describes the rate the velocity changes. And so the longer time, the more change. In velocity. Alright, so that's what I would have for my y. Trying to understand what acceleration is, and understand that the time is affecting how much it changes. Now, let's see, equation-wise, I want, they tell me I have this acceleration, I've got this much time, so I'm going to look for an equation with acceleration and time, and they tell me I end up this final velocity. And they want to know what an initial velocity I have. So I would love to find an equation that had acceleration, time, final velocity, initial velocity. Oh, I have one. Alright, so let's use that one. Okay over there? So now, let's see. This says V final equals V initial. So my final velocity, my initial or starting velocity, plus acceleration multiplied by time. So this part here is the part that tells me how much my velocity changes. Notice how that corresponds to my y, right? Acceleration and the amount of time. You guys looking at this assignment on those, right?
Yeah.
Dana? Please do.
It's asking for it's asking for the beginning, so you have to.
Do you want me? So I want that initial one. This is the one it's asking me about. Do you guys, should we rearrange now or put numbers in and then rearrange?
Oh, rearrange now.
Okay, I heard two numbers in, so we're going to put numbers in and then rearrange.
Who else said numbers?
Indeed.
Oh,
So let's be nice. Let's be nice to each other. So 5.30 meters per second. That's the acceleration. So I'm going to put that in. Plus 5.30 meters per second squared. The next number it tells me 0.0256 seconds. So that's my time. 0.256 seconds. They better not tell me what my V initial is. If they have, it's just useless doing this. And they tell me my final, positive 9.51. Oh. 9.51 meters per second minus, so I'm just going to subtract that whole term from both sides. What are you questioning about yours? From mine told me I had an acceleration of 5.30, a time of 0.256 seconds, and a final velocity of 9.51.
So,
And I do a little calculation, I get 8.15 meters per second.
So you're multiplying your s squared and your s.
My acceleration and my time, yep.
And then you have to subtract it.
Yep. Remember, to subtract, I need both to have m over s. That's so I do my multiplication first. Plus. Alrighty, here we go. So, landing with the speed of this and traveling due south, the jet comes to rest in this. Ooh, if it comes to rest, is it speeding up or slowing down? What has to be true of the velocity and the acceleration to slow down? They have to be opposite. So if it's heading south, which way does the acceleration have to be? North. You know that right off the bat, right? Cool. That's one of these things. Find the magnitude and direction of its acceleration. Oh, we already figured out the direction. Woo, we're half done. We haven't even touched the pen yet. Woo, woo. Nice. So, let me get the size right. So this is number 3. So velocity and acceleration must be in opposite direction of each other. Oops. To slow down. And the other thing I'm going to say is the larger, seems slide, yes, the acceleration, the less distance needed to stop. Because not only do I need to know they're in opposite directions, but they're telling me about the distance. And so I need to realize that depending upon the acceleration, that distance is going to change. So, they tell me about the initial speed I start with. They tell me how far I travel when coming to rest. And they want me to find the acceleration. Oh, and coming to rest, what do they tell me the final velocity is? 0. We tend to just forget that, but it's good to point out. So I know the initial velocity, I know the final velocity, I know how far I've traveled, and I want to know the acceleration. So again, I'm looking to see, hey, what's the relationship between those 4 things right off the bat? So I grab my equation sheet. In that acceleration box, is there an equation that talks about speed, velocity start at, velocity end at, Your distance and your acceleration.
The one that we used in the last problem.
That one talks about time. Now maybe I could use that and figure out time something.
Wouldn't it be the one under it?
The one under it though gets rid of that time, right?
Oh.
And it has this.
I was asking how long it took.
No, it wants to know the acceleration. So I think that's our best one.
Yeah, it is.
Now, not every time will we be able to find an equation that has everything we exactly want. Then we might want to look at, oh, okay, wait a minute. If I find the time, maybe then I can find the distance, things like that. All right? So don't think it's always you have to find just a single equation. You may have to work your way up to being able to combine things. So the thing to be careful on this one is the fact that the velocities are squared. And those actually are speeds, not velocities. But be careful of that. That's the most common mistake. So let's put in what we know. So they tell me, the initial speed, 76.9 meters per second. So that would be in here, 76.9 meters per second. I'm not going to forget that squared term. Plus, they told me the end one, right? 0. I don't know A. And then they tell me the distance, 936 meters. Oh, nice. They didn't even, 36 or 63. 963 meters. Nice. They didn't even mess with units on me, right? Oh, I should have asked, did you want to rearrange first or do numbers first? But, all right. Yeah, it does. So I'm going to move that over to the other side because it was added on this side. Remember, I do sneaky math.
You said you do sneaky now?
I do sneaky math.
I thought you said you do sneaky now. I don't know what that is.
Well, it's math from the 1920s when math was on prohibition. You had to do a speakeasy to get to be able to do math.
Yeah.
They talked about it in Great Gatsby.
We already read it.
We're just now starting it.
Oh wait, yeah, I know.
That's what teachers are close.
Would you guys do that?
We're doing it right now.
All right, so, I can rearrange this a little bit more using my magical algebra. Sometimes it seems like it is. Sometimes you feel like it is. Oh, I'm going to get a negative answer.
No!
Oh, that's because it points south, right?
True that.
Oh, so we got confirmation that we were right on the south part.
Wait, is it supposed to be a big number? Because I got -3. I got -36261.9.
I got 3. Now, be careful of your math, because if you just put in 76.9 squared divided by 2 times 9.963, you can divide it by 2 and then multiply it by the 9. I put parentheses around mine.
Oh, so it doesn't. So now we.
The 2 and the 963. So it did that first, then divided by top line. So I get negative 3.07 meters per second every second. Right. So it wants magnitude. You just give the positive value of that, and then the negative comes into the south.
Yeah.
Let me come over. Let me pause my video now.
I use.
Mine says traveling due south. I thought it said traveling due north. So I hope at the beginning we said that the acceleration should point north. Huh. Really strange. Because in here we'd have a negative right there. Let's see.
So you're not really a mathematician.
I am, but I get bored with math.
Oh, sure.
You'd have a negative right there. And a negative right here. That'd be negative. That would mean this would be positive, and that would be positive.
So I got it right.
I don't know why.
That's the end of class.